If you're looking for an external VSWR meter, then I've got one here which I think might interest you. It's very versatile as regards frequency coverage and also very versatile as regards power coverage. It's quite possible that this VSWR meter would fit into your station and cater for most needs. Now, some will question whether you need an external VSWR meter because there's one built into the transceiver. Well, later in this video I will show you why I think an external VSWR meter is desirable, in addition to the one built into your transceiver. We're going to take a look at the Daiwa CN-501H2, a VSWR meter which I've had for a little while now, and I've been very impressed with it because it does an awful lot of things and it's also very rugged. So let's take a look at this VSWR meter. The meter movement on this device is a cross needle meter, and if you haven't used one of these cross needle meters before, then I'll explain how it works a bit later in this video. But it's a nice large clear display. The meter measures 270mm wide by 70mm high, and the overall depth is approximately 100mm. As I said at the intro, it's quite a rugged meter, and it's got these rubberized buffers either end, which if you wish can be removed, but it enables it to take a bit of rough and tumble. On the back panel we've got a pair of SO239 sockets, and to the left you've got a DC input there to illuminate the meter. And here you can see the meter illuminated. The meter covers 1.8 to 150 megahertz, so it covers all the HF bands and the 4-6 meter band and the 2 meter band. It covers the power levels 20 watts, 200 watts and 2 kilowatts, so you can see that it covers a wide range of power levels and makes it suitable for many operators. And then on the right hand side you've got a button which selects either average power or PEP power. To select the appropriate power range you press one of the buttons, and below the meter there's 2 holes for zeroing the meters. Let's take a look at the cross needle meter readings on this meter. You actually get 3 values. On the left hand side you've got an arc which goes from 0 to 20 watts. You interpret that as 200 watts at the medium power level and 0 to 2 kilowatts when you're on the high power level. On the right hand side you've got the reflected power, 0 to 4 watts. You interpret that as 40 watts at the medium power level and 400 watts at the maximum power level or the highest power level. Then SWR. SWR is indicated at the point where the 2 needles cross, and I'll show you that in practice in a second. One of the good things about this meter is, of course, it doesn't need any calibration. There's no knobs to twiddle. It's all pre-calibrated. I took the covers off to have a look inside, and the construction looks very good. Very high quality components and typical Japanese engineering. Now let's see how we read the VSWR. I'm operating on the 40 meter band. I've got 10 watts power output, and if you look at the SWR scale where the 2 needles cross, it indicates we've got a VSWR of about 2.3 to 1. So you see how the VSWR can be read even when we're reading power output and reflected power. In other words, you've got the 3 readings, and VSWR becomes very obvious once you understand that where the needles cross is where the VSWR is. As for power accuracy, I was pleasantly surprised. It was very accurate when I compared it with the bird through line. Do remember that if you want to get the most accurate VSWR readings, you must insert a line isolator just at the point where the antenna down lead connects to your VSWR meter. Now when it comes to making accurate VSWR measurements for aerial adjustments, you need a steady carrier, and I tend to select AM mode because AM mode gives you a steady carrier.
Usually it's limited to around about 25 watts, but you don't need a lot of power to measure VSWR. So I would set my power level to about 10 watts, and then when I press the PTT button or on the microphone, I get a steady carrier of 10 watts. If I'm transmitting on SSB and I've got the button there set to average, when I transmit, you'll see that the meter goes up quite, it's got in a sort of spiky sort of motion. Let me show you. Hello test, 1, 2, 3, 4, 5. Hello test, 1, 2, 3, 4, 5. Now if I press the PEP button in, you'll see a different display. Hello test, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, hello test. And you'll see what actually happens there is that the meter movement is dampened. So for SSB monitoring, you'd normally leave the meter button on the far right to PEP. If we leave the SWR meter set to the PEP setting, it's quite an easy way of adjusting the mic gain control. Let me show you. I'm now going to advance the mic gain control. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, hello test. 1, 2, 3, 4, 5, 5, 5, 1, 2, 3, 4, 5, 5, 5, 5, 1, 2, 3, 4, 5, 5, 5, 5, 5, 5. That's about maximum setting or best setting. Beyond that, increasing the mic gain has no benefit on the RF output. That means to say that the mic gain on my FT710 was actually set to around about 55 out of a maximum possible gain of 100. Now let me also show you now how it's quite an easy way of adjusting the processor. At the moment, when I transmit, I'm going to have no processing in, and then I'm going to gradually increase the level of the processor on the FT710. So let's take a look at that. Right, I'm transmitting now without any processor at all. I'm going to start to increase the processor level. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, hello test, 1, 2, 3, 4, 5. You can see the dramatic increase in the effective power output as I increase the processor. If I turn the processing down now, you can see the power falling markedly there. So let's take it back up again, 1, 2, 3, 4, 5. So it's an easy way of setting up your RF or your compression on the microphone input on the FT710. In actual fact, I found the best setting was 37 on the FT710, but you can see the SWR meter will enable you to actually adjust the levels of the mic gain and the compression and see the results on the RF output display on the meter. Let's finally discuss why, or another reason why, an external VSWR meter is desirable. Almost certainly your HF transceiver will have an internal VSWR meter and also probably an internal antenna matching unit. You might argue, well, if I've got a VSWR meter built into my transceiver, why would I need an external one? Well, when you press your antenna matching unit on your transceiver to get a really good VSWR, the meter on the transceiver shows a very good VSWR. It's got a nice match, or it sees a nice match, and therefore it delivers full power. But in actual fact, it doesn't change the VSWR actually on the coax line. If you have an external VSWR meter, then that is telling you the truth. The internal VSWR meter on your transceiver says, okay guys, you've got a perfect match, I'm going to deliver full power, which it does. But it doesn't actually change the VSWR. So if the VSWR on your line to your antenna is gradually changing or getting worse, it's likely that it won't be noticed on your internal VSWR meter. But if you have an external VSWR meter, that will tell you the truth, and it will alert you if the VSWR is starting to rise. And of course, it's also nice to see what sort of power you're getting out of the transceiver with an independent meter. So that's my take on the VSWR meter. The VSWR meter for all reasons. It's quite a useful device, but it's essential that you make sure that when you do buy one, it's fairly accurate. Now this one from Daiwa I found was extremely accurate. Interestingly enough, they say that the accuracy is 10%, well, or plus or minus 10%. Well, I would say it's much nearer 2 or 3%, because I found it very, very accurate indeed. So if you're thinking of getting an external VSWR meter, then put the Daiwa one near the top of the list. It may well be a VSWR meter for all reasons. There we are. Thanks for your support on this channel. Thanks for the support on the website, the shop, etc, etc. Much appreciated. Don't forget to press the subscribe button. And well, this is the first video of 2025, and there's a lot more coming. In the meantime, you enjoy your ham radio, you take care, and as usual, I look forward to seeing you in the next video. Bye for now.